Welcome friends again to the session of marketing research and analysis. We were in the last session we were discussing about the experimentation or the causal effect basically, in which we talked about causal research has two basic parts. One is the in the field experiment, right, and the other being the lab experiment, right. So, where research is being done either in the lab or on a set like the field, right, on let us say on people at large in the public domain. So, you can experiment to see how a variable affects, right, and the variables being the we spoke about was the dependent variable and the independent variable, right. So, the dependent variable is basically the y, which we say is the effect, right, and the independent variable being the x, which we say is the cause, right. So, this is the cause which affects which and that is the effect, right. So, what is the effect, let us say of let us say the film's income, let us say income is how income is affected by the popularity of actor, right. So, this we are trying to measure, and we see if we suppose change the actor, is there a change in the revenue, right, or the if suppose you must have seen in sitcoms and all this the programs basically where they change an actor in between the serial, right, after some time. So, what happens is basically why does it do it? They try to see whether they feel, they have a hypothesis that if we change this actor, maybe our program will do better, right, they will pull in more consumers, more eyeballs to the program, and people's interest for the program will increase, and that is why they try to change, and sometimes it also helps them in breaking the boredom, right. So, we did with the we started with the experimental design, right. So, the pre-experimental and the true experimental we said, in which we had there was pre-experimental, this is the one shot case study and all, and this is the true experimental where we had pre-test and post-test both. This has got an advantage, but the third is basically what we are now discussing is the quasi-experimental. So, what is the quasi-experimental and why it is different from the others, right, for example, the pre-experimental and the true experimental. The basic difference between the quasi and the others is that a quasi experiment, right, basically does not have the element of randomization or randomness, right. So, that randomness is missing in the quasi experiment. So, why does it how can we explain this? Let us say there are situations where we do not have the ability to randomly place somebody, because in fact the biggest advantage of experimentation is to have randomization, right. That means what you can say, as I was showing in the last session. So, let us say there is a field in which you have divided the field into several levels, right, and you want to randomly put in the let us say fertilizer. So, you may put it here and here, and you do not want to put here. So, this may be like a control group and this is your treatment group, right. So, this thing is very helpful in research, because it helps us to find out what exactly is the effect of the treatment, or is there any real effect of the treatment, or there is no effect by just measuring the difference between this and this group and this group, okay. So, but the quasi experimental group is something where I will give an example. If you see the time series and the multiple time series. Now, let us take an example, very nice example. Now, suppose you want to check what happens when people are given different doses of medicine, right. So, in those cases when medicine doses are given, it is impossible for you to have a test like, for example, let us say suppose we give treatment, right, and we will not give any treatment. So, this is not possible. Why it is not possible? This is not possible because the simple reason is unethical. How will you allow somebody not to be treated, right, just to make an experiment? We can't do that, right. So, in such conditions this is the difficulty which we have, and that is why studies which fall into this category where you are not able to do a random experiment, right, in those cases are called, come under the quasi integration, not quasi integration, sorry, quasi experimentation. Okay. Quasi experimentation. So, let us take these two basic examples. So, as I said one, I hope you understood that when you do not give a treatment, always it is not possible. So, randomly you are that random factor is missing in this quasi, right. So, now as it says, look, this is the time series design which I have taken, right. There is no randomization of the test units to the treatments. So, this is the biggest difficulty. For example, one of the classic is, suppose you want to test it on a person, right. Now, you want to see the effect of a particular drug or a particular promotion on people's age, right. Now, here the biggest problem is that, suppose we try to test it on A, let us say A being an individual, right. Now, we can do one thing, suppose A is a particular age group of let us say 40 to 50, let us assume, and we want to see how it varies for 40 to 50 and 20 to 30, let us say. Okay. Now, the problem with such kind of studies is that 40 to 50 if we do, and this is suppose 2 or 20, they are two different people. Please understand this, there are two different people. So, 20 to 30 is one person whose behavior, although we are saying age wise they are different, but they are two different people whose characteristics might be entirely different, but we do not have an option. Why we do not have an option? We cannot do this, that we will try to bring this man back to 20 or 30 and do the experiment again. Yes, one thing is possible, that if you can do, like for example 20 to 30 when at this time period you do it and then again you do it at this time period, maybe it is possible, but otherwise the reverse is not possible. Okay. So, the timing of the treatment presentation as well as which test units are exposed to the treatment may not be within the researcher's control. So, why I will be saying time series designs? If you see, time series designs are basically where let us say the in a typical time series design, which we say the people are they are what do you say, treated, you can say they are treated to, for example, on a particular let us say the income of people are being measured, for example, let us say the income of people. Now, what we are doing for year wise, we are doing it 16, 17, 18, 19, 20. So, when we are doing it basically, right, we are keeping the same people, right. So, keeping the same people helps us to at least do our research in a better way to understand, because this researcher has not changed, he has been more or less the same, right. So, that is why we have been able to control it to some measure. Otherwise, we cannot most of the studies in economics, you cannot put it in a truly experimental condition. It is very difficult to place in a very truly experimental condition what happens if they are not given and what happens if they are given. So, if you do that, there will be two different elements altogether, right. So, that becomes, and on the same person you can't make the experiment twice, it is impossible, because you cannot regress the person, the age of the person, right. So, that is one problem. But one multiple time series design is one where we have two groups now. So, the observation is taken for the experimental group and there is a control group. Now, what is saying, if the control group is carefully selected, this design can be an improvement, although that flaw will remain, what I said, right. You cannot take back the person to his age of 20 to 30 again when he is already 40, can be an improvement over the simple time series experiment, right. Can test the treatment effect twice against the pre-treatment measures in the experimental group and against the control group. In the experimental group you had that pre-condition and post-condition, which exactly might not be able to replicate, but at least we can figure out what is the best possible solution that we can achieve. So, quasi-experimentation are basically experiments where you do not have that randomness to use the randomness characteristic. Okay. The fourth is these three which comes in the randomized block, right. Now, let us see what are statistical designs. Statistical designs for example are basically used for a series of basic experiments that allow for statistical control and analysis of the variables and offer the following. What are the advantages? the effect of more than one independent variable can be measured. Now, please understand when you hear something called like a factorial design, right. A factorial design is nothing but one factor is nothing but an independent variable. One factor is nothing but an independent variable. So, if you are doing a factorial design or even a Latin square, which is nothing but kind of a factorial design, what we do is basically we are saying the effect of here more than one independent variable can be measured. Now, what are the let us say independent variables you want to measure? Let us say you want to see ki whether score gender right and plus hard work, right. First let us say take one, gender affects the let us say score of a person, how much he is scoring in let us say mathematics, the math score or any score, for example math score, take example. We will say that gender has an effect on the math score, that means girls let us say in terms of maths we will say boys score better than girls in maths, and it had it been let us say English or something or a subject like that where a lot of abstract and theory is required and the logical understanding is required. So, there maybe girls would have better, but in maths we say suppose that let us hypothesize, it could be wrong also, that gender does an effect, that means male we are saying are having a bigger better role to score better than the girls, okay. But that is not enough. So, gender has two levels, let us say male, female, okay. Plus we are saying ki suppose we want to also know ki the amount of hard work, let us say amount of hard work or hard work also plays an important, or you can say the school, in which school they are studying, the kind of school they are studying, let us say public school, private school, so school, right. So, the school they are studying also. Now, we are having let us say public medium and state medium, let us say, or public and private, simple, because I do not want to get into this thing. So, public and private. So, now when I am having I want to check the effect of the people's score, I feel ki one, that gender has an effect on the math score. Second is the type of school also has an effect on the score people do get in maths, right. So, when I am doing this is basically what falls where we are trying to test more than one independent variable, okay. And here the advantage is that extraneous variables, which if you remember in the last session we had discussed, extraneous variables are those variables which are basically not exactly the independent variables, but they are still variables which affect the entire experiment or the entire study, right. So, okay. So, these are basically the statistical designs. Statistical designs have been done to bring in the randomness factor into it and reduce the number of experiments to a limited number, okay. The most common statistical designs are the randomized block design, the Latin square design and the factorial design, okay. Now, let us see. It is useful when only one major external variable such as store size might influence the dependent variable. Now, what it is saying? Now, there is only one factor in the randomized block design, you have only one factor you are taking. Let us say the factor could be store size. Now, the size of store could be big store, medium size store, small stores, right. That can have an effect on the let us say the dependent variable, that is sales, for example, okay. So, when you have such kind of a block, you are trying to study the impact of store size, then what we do here is the test units are blocked or grouped, right, and then they are tested. The blocking, the researcher ensures that the various experimental and control groups are matched closely on the external variable, right. So, basically what is happening, if you look at this randomized, now this is for example, this is a treatment group, that there are three basic commercials, okay, commercial A, B, C. Now, we are saying patronage is heavy, medium, low and no patronage is basically loyalty, okay, none, to simply understand. So, what we are saying, does the commercial have an effect on the loyalty of a store. Now, what is our what loyalty is? Now, loyalty or patronage is our dependent variable. So, we are saying that means the equation will look something like this, ki P is equal to, let us say, A plus B of the type of commercial, the X, where X being the commercial maybe, right. So, the patronage is getting affected by the type of commercial, we are trying to see this. So, this is one block, this is the second block, this is the third block. But this, although this is a randomized block design, sometimes we also use, before, which is not there in this slide, is something we call a completely randomized design, which is not I have shown here, but I will show you on the board. There is something called a completely randomized design. Now, what is a completely randomized design? Suppose in this case only, suppose you would have taken, let us say, heavy, medium and low, let us forget the fourth one, and let us say we take the commercials, okay, the commercials. Now, what we do in a randomly design, random is we try to put it randomly, anything, right. So, first A, B, C, na? A, B, C, A, C, B, B, A, C. So, we do anything. So, what happens is when we randomly assign the values, it is very simple. This is called a completely randomized. It is very simple, there is free of bias, everything is good. But the problem here comes is that when you do a completely random, there is a problem that two elements might be tested at one point of time, and maybe some other element is not checked equally. So, there might be unequal weightage given. So, that can be one of the worrisome factors. Okay. Now, look at this, for high there is A, B, C, for in terms of every one is there, but here there are 2 A's, right, and here there are 2 C's, right. So, this could be a problem which can happen. So, then comes the randomized block design, where what it was done was to randomly the one block is made and then they are tested, okay, completely random, first block A, block B, block C. So, by doing this, a complete block is being tested, for example, okay. The second is the Latin square design, which is very close to the you can say similar to the factorial design. So, here we are able to manipulate the independent variable, right. Two non-interacting external variables, the statistically the researcher is able to control the two non-controlling statistically controlling two non-interacting external variables. So, the interaction effect, what do you mean by interaction effect? First let us understand. Interaction effect means A affects B, let us say something like this, let us say A affects B or B is affected by A, okay. A affects C affects B, C affects B, right. Now, although these are independently affecting together B, but there can be a third thing, that A and C together also have a way of affecting B. Now, why are we doing it? Sometimes in life it happens that two things, which is sometimes you talk it in terms of synergy also, right. Two, or let us go to science, we understand it like a reaction in which a fusion reaction, where when two elements are meeting together, the interaction effect is larger than the main effects, right. Or sometimes it could be also that the interaction effect is actually negating their values and it is pulling the overall effect down, right. So, the presence of an more than one variable is generally one should test for the interaction effects, which is very important in research, and in most of the research publications and all you will see that there will be question why the researcher has not gone for a test of variance, why have they not gone for a checking the interaction effects of the variables. So, that is basically to understand it is a simple, it is like when you and your wife is there and your mother-in-law is there, and they independently have an effect on you, but when they come together in the same house, the effect becomes either very detrimental or very on an humorous side, or very highly positive, okay. So, that is what, okay. So, each blocking variable is divided into an equal number of blocks or levels. So, let us see how it looks like, this Latin square design. The simplest way of making a Latin square design is, you just have to remember, is have this way. Suppose BAC, then you start from here CAB, right, then CAB. So, what is left from, you start again from here. So, suppose you do not know how to design a Latin square design, you can just remember like this ABC, now leave A, come BCA, right. So, BCA, now leaves A, so CAB. So, this is how simply you can design a Latin square, so that every item is given an opportunity. Okay. So, when you do this in the Latin square design, a Latin square design is called an improper factorial design, sometimes it is said. Okay. Okay. So, basically it is nothing but a kind of factorial design only, right. So, what has happened now, every element you see has been given, like, there is a kind of equal opportunity. So, B, A, C, C, B, A, nothing is being repeated. Okay. So, Latin square has got one requirement, please understand, that is why the name square comes into here. So, a Latin square design whenever you make, you have to have equal number of rows and columns. Suppose you make 3 rows, then 3 columns, 4 rows, 4 columns, 2 rows, 2 columns, 5 rows, 5 columns, but you cannot take it to a very large extent because the test will become too clumsy and complicated. Okay. Now, this is also the factorial design has got a larger benefit than the others. Now, what is happening here? It is used to measure the effect of 2 or more independent variables or factors at various levels. See, that is the basic advantage. In other studies and experimentations, we were missing out the levels. So, in these statistical designs, we are measuring the levels. So, let us say gender had 2 levels, 1, 2, let us say 1 female, 2 male, right. School, so we had 2 levels, it could be 2 by 2, it could be 3 levels, right. So, 1, 2, 3, let us say government, something NGO run schools, let us say these are private schools. So, the number of levels at various levels, factorial design helps you in improving exactly allowing you for the interaction effects basically. So, that interaction effect was not possible in the Latin square design, right. A factorial design may be conceptualized as a table. In a 2 factor design, each level of one variable represents a row and each level of one variable represents a column. So, what is saying? Each level of one variable, right, represents a row and each level represents a column. Now, for example, let us say, now this is a factorial design in which what we have done is, although it looks very similar, right, it looks very similar, but here the advantage is that in every element has been given an equal opportunity, right, has been given an equal opportunity. So, in a factorial design what happens, the interaction effect also comes into play and every the randomization happens, right, it is randomly the randomization factor comes into play into the system and this becomes more richer in experimenting and getting values. Okay. So, a researcher can get a better output, right, when he uses a factorial design because each factor or each independent variable with its level is being considered as a table in the form of a table. Okay. So, this was basically what we had for the experimentation. So, I hope you must have been able to understand that means during this process we had in the experiment we tried to understand what are the types of experimental designs and why should you do it, because every marketer, every marketing application has a requirement of causal research and the experimentation, right. So, when you do any field test or anything you require it, right. So, okay, let us see now when you are doing any experiment, after the experiment you need to also understand whom are you going to work on, right, who are your samples, right. So, what is a sample and what does it mean basically? A sample basically let us understand a sample you have to understand it as a true representative of a population. So, what it is saying? A true representative of a population. Okay. So, samples I will just brief, maybe we will continue in the next session. So, the samples are basically in any study you need to understand that you cannot measure the whole population. Suppose this board is the population, you cannot measure the whole population. So, in order to avoid that, we need to have a sample which actually is a part of this board. You cannot take this part as your sample, because this is not a part of the board, right. So, it has to be part of that population, it has to represent that population. And sample basically how does it help? Now, samples are used to make estimates of the larger group. That means, a sample tells exactly whether it is actually defining the population or not, right. And what we do is basically we try to find out the difference between the sample and the population through its mean or something, and then we say whether the sample is actually explaining what the population should explain or what the population would explain or not. Okay. So, two key elements, it is faster and cheaper, obviously you cannot the population being larger. Selecting the right people. So, when we are talking about a sample could be a person. In marketing research we will obviously take in terms of but a sample does not mean people only, my way of putting it might not be correct. Sample could be anything, it could be the sample could be a product also. So, from a population of elements, let us say machines or chairs or tables, or let us say this pointer. So, what we have. So, if suppose a company is manufacturing, we can pull out a sample, a few samples and test what should be the standard specifications or the characteristics of this sample, and whether these samples are actually defining properly, meeting those requirements, and if yes, then we will say that actually then if this sample is good, then the population must be good, right. So, sample basically helps you to identify from a small way whether the population is correct or not correct, right. So, this is what basically is explained, but in terms of marketing we will say selecting the right people and selecting the right number of the right people, two things very important. So, sampling says you have to first let us say if you are conducting a study, let us say you want to check let us say the use of this marker, right. So, whether this marker is good, effective or not. To test it you can ask anybody, right, but the best people to talk about it would be people like me who are regularly using it, right. So, although age might not be a factor, but yes, the profession could be a factor in deciding who this product should be using. So, the sample when you take out a sample or pull a sample, one is to understand that the sample should be a correct sample, he should be able to explain the thing, the phenomena, and then after that if you take only maybe 10 people, that might not be justified to give a true representative, right. So, in such situations what should be the sample size, right. We can use also formula to calculate, right. So, we say this is how from the z score, or I think this will not be visible, I need to. So, what we will do is z is equal to x minus mu. So, this is 1, this is my standard error. So, through this also, that this being this is equal to root over n. So, from here also we can find out, but there are some thumb rules also which I will explain maybe in the next session, how do you understand sample, how to use sample. If you get a wrong sample, then there is a large obviously your study would be fruitless and it will be a waste. So, and misrepresentative. So, the point is you have to understand that who is my right sample and how many samples should be taken. As a researcher or a executive also in a marketing research study, you should be able to understand how many samples should I collect, so that my whatever I am stating at the end about the population is coming true, right. Well, this is what we will have in this session, we will meet in the next session. Thanks.